Welcome to the Fast Mode podcast series. I'm Tara Neil, and with me today is Charles Yeomans, Chairman and CEO of Atombeam. Atombeam is redefining how data is stored, used, moved, and secured. The company's innovative data as Codewords technology increases available bandwidth an average of 4 times, improves access to stored data by making it searchable while encoded, and enhances security with ultralight software, all in a single computing step. With 25 years in executive roles and investment banking, Charles has led multiple firms and founded successful companies, including major insurance brokerages. Charles joins us as part of our exclusive editorial segment on Gen AI for network management. Welcome, Charles. Great to have you on today's episode.
Great to be here. Thanks for inviting me.
Awesome. Okay, let's begin. We have this interesting term that we came across when we were looking at Atombeam. So the concept of data as code words. Can you explain what it means and how it works?
Sure. Yeah. So data as code words is really at its real core is a rethinking of data itself, how it's structured. So if you think about how data has been almost since the inception of digital computers, it's really taking a word or something understandable to a human and turning it into bits. And we think, and we came up with a process that says, wait a minute, that's not the most efficient thing because computers have capabilities that humans don't. And the way data works in a computer doesn't have to accommodate humans. And so what we said instead was like, look, we can use small representations of larger chunks of data. Specifically, we call them code words that are gleaned using machine learning from a data sample. So you might have a bunch of temperature sensors or other kinds of sensors measuring things, or typical IoT type thing. And so what the kinds of data they generate would be, all this kind of things like time and location and battery power and stuff like that. So all that stuff is highly repetitive. And what we said was like, look, you don't need to have all that repetitiveness. What we can do instead is represent that. So the things we see a lot in that data might be patterns of data might be 128 bits, 64, 200 bits long, and represent them with much smaller code words. They might be 3 bits or 10 bits or 5 bits. Depends how frequently you see it. And so at the end of the day, to a computer, looking at a 3-bit, 5-bit code word might have the same, the computer might be able to, in that same microsecond, recognize that is actually not just that little code word, it represents 128 bits or something. And so the consequence of all that is that computers can be much, much more efficient. So can networks, so can everything. And this could impact literally everything that is connected to a network and in every single thing because it's just way more efficient and it adds security when you do it.
Wow, that sounds really interesting, but at the same time, it's not very easy to comprehend. So I'm just going to clarify a few things.
Sure.
So if a computer has a code word, is given a code word, can it have the same visibility into the entire data as a computer that has the original data? Or is it just an understanding? It requires an understanding, but not the actual data.
Well, here's the key thing that computer with a code word needs. It needs a code book. And the code book has a bunch of code words in it, thousands usually. And each code word is matched up to a pattern that found in a data sample. And so you would say, okay, to that computer, here's a code book. And then when you see this code word, the code word to that computer can be, boom, translated in a few millionths of a second into if as long as it has a code book, into that pattern. And so when you put it all together, it can, because it's so fast, because you're using what computers do really well, which is highly repetitive
Yep.
tasks really fast. And so, yeah, to the computer that has a code book, it's just as visible and usable as a computer with the original data.
So basically, it does have the entire data set. Once the translation is done using the code book, it has access to the original data or the copy of
Yeah,
that
it
original
does.
data.
It can translate it like that,
All right. Okay. Wow.
like
That sounds really
faster than
amazing.
that.
Yes, it's
Yeah,
it's really
it is.
really an amazing concept. So okay. So given that I think you touched a little about the benefits of having the data stored as code words. So what advantages, like other advantages compared to traditional methods that we expect to see by implementing or moving to a code word kind of architecture?
Right. So it's really it impacts two things. One, it's a network. Now, effectively, on average, we reduce the size of individual little IoT files, which you can't really use compression on because they're too small. But we impact them by reducing them in a couple of microseconds by an average of 75%, which means you can effectively quadruple the bandwidth that you have. The other thing is, once it gets there to wherever you're storing it, a really cool aspect of this thing is that we call it NURPAC, is that you can just send the data in this reduced form, this compacted form we call it, and you just store it. You don't need to compress it. It's already small.
All right.
And so when it gets there, it's small, and it's also homomorphic because you can actually search and randomly access the encoded data if you have the codebook, as we described a moment ago. And so that's a really cool thing. The third thing is advantages in storing. So when we translate things into code words, data into code words, then we're deeply obfuscating the data. It's becoming it'd be very challenging for someone to hack a code book because it's thousands of randomness and it's just representing patterns, not something in the real world like a letter or number. So when you add those things up, you're adding significant security. But we also, later this year, expect to release at the same time it's doing its compacting, NURPAC, we call it NURPAC Plus, will be able to also encrypt all at once. And
Oh
it's
wow.
super light and small, right? And this is like incredibly light. It's like it'll work on a 10-cent chip, and it'll encrypt it and compact it. It gets it almost as small if you're encrypting also. So not only you're obfuscating, you're also encrypting. And so when it hits the data center and you store it, it's still homomorphic, still usable, searchable, etc., and it's encrypted. So once it's in this data center, a lot more usable in its small form, and if someone steals it, it's protected, it's encrypted.
Wow.
And if they don't have the code book, too bad.
Too bad. So we are looking at three major advantages, which is the first one, bandwidth. Lots of bandwidth savings, because if you transfer this data, you're gonna just transfer it in a compact form, right? So you're gonna require much less storage. And thirdly, on the security aspect, like what you said, it's obfuscated, and when you guys bring in the encryption as well, so you're gonna have like lots of data security on this. Okay.
Exactly.
Yeah, and you've mentioned about IoT data, right? So that's a specific type of data, and it's a repetitious kind of data. So can this same technology be used for other types of data, like non-numerical data, like images or maybe text data and stuff like that? Does it work the same?
Well, we depend on patterns repeating, which means that we focus on data that tends to be repetitive, tends to be low entropy. And so texts, yes, we've tested texting, we've tested SMS, we've tested syslog files, you name it. All sorts of things that aren't IoT data, which is also low entropy. But if you're talking images, if you're talking video, no, that this is not the right thing because the point of compression in video compression, video codecs, is to eliminate patterns,
Oh,
right? I
okay.
mean, that's
Yep.
what they're trying to get to, and so we can't do anything with it when it's been already compressed. It's just how it is.
But you are already tackling, I think, the bulk of the data types that we are handling today. All the text and
True,
SMS,
true.
syslog, and stuff. Yeah, those are that's what comprises most of the data that we deal with. So, talking about images and videos, let's look at this new topic, which is Gen AI, right? So there are a lot of Gen
Yep.
AI applications, and the at the center of Gen AI is of course data and lots of data. And I think data that we have just discussed, IoT data specifically, really is one of the major inputs for Gen AI applications. So how does this technology that you have is expected to impact Gen AI applications? And what are the outcomes that we can expect, like in terms of performance, reliability, security, and stuff?
So, Gen AI is something we are spending a lot of time on, and we've actually already built a version of an LLM, except it is not an LLM. It uses code words instead of language. And the cool thing about code
Wow.
words is they're
Okay.
small, right? They're a lot smaller, and they represent whatever you like. They're fully multimodal. They're not just language.
Yep.
It can represent a letter, a number, whatever you like. It can represent an image. And so if you add it all up, you'd say, okay, this is pretty cool. What does it really mean? Well, we've built a Gen AI, and the Gen AI is it'll fit on a cell phone. And it still draws upon the giant AI in the cloud
Yep.
when it needs information, but it can operate fully on just a cell phone. Right now we're on a laptop, but we think it'll be when we're done, we'll have a fully functional version that works on a phone. So in terms of like what's the impact of that? I mean, pretty good. You
Yep.
could have a completely functional Gen AI on your phone, and for most purposes, it doesn't need to even talk to the cloud. It could be disconnected from the cloud and still operate.
Wow, I think it's really a radical concept, and you just
It is
mentioned,
radical.
yeah, it's radical because
It's cool. You understand what we're talking about. This is
yeah,
great,
yeah,
right?
because we have the LLM models which which go for text, all text-based sources, right? And then we have the alternative models like diffusion, VAEs, and GANs, and all that. That's for the non-text stuff. And then you bring in now a new type of source of information, which is code words, and then that would be in the family of non-text, and therefore now we'll be looking at a new breed of algorithms. And I guess because the model has to learn differently. It's looking at a new genre of inputs, and I guess you guys are doing something great. Given that the
It's,
kind of things that are taking place in the Gen AI space right now.
well, yeah, and so we asked Perplexity, like, what is the potential total addressable market for just for NERPAC? Not really addressing the AI piece.
Okay.
It estimated $1 trillion.
All
You know,
right. Wow.
so I'm
Wow.
too pushing to do $1 trillion or something. But it's because if you think about this, think about it like to go back to NERPAC for a moment, and like it the what we're really talking about here is with NERPAC is we're talking about something once we put it on a chip, which is a goal we have. We're going to hopefully crank that up later this year. We put it in a chip, and now because like I got to tell you, I don't know how many people have asked me for this, but if you could, like one of our big partners is Ericsson. Ericsson's working with us to put it there. They're selling it in the context of their gateways, their IoT gateways. It's just a start, but it's really promising. If I could sell them a chip or an IP core that would go into on their board of the next generation of their products, then I think they would do it. I think a lot of people would do it
Yep.
because if you think about it, what is like you look at IoT,
Yep.
98% has no security.
Yep.
And the amount of data that's trying to get through the pipes is enormous. Like according to IDC, 90 zettabytes will be generated from IoT this year, which is staggering.
Yep.
It's like
It
it
is.
doesn't. Yeah, it is. And so, and the pipes can probably handle less than 1% of that. And so you say, well, I mean, what are you going to do? I mean, you have to do something to move all that data better and store it and make it more secure when it's there. And it's like, and homomorphic. And so you add it all up, you'd say, well, if I had a chip, if I only had a chip,
Yep. Yep.
then, we could sell it to anybody and everybody. And there's all these advantages, even if all you do is send it and that's all you really care about. And then you translate it back and compress it or do whatever. That's still a huge advantage. So I think that, right now we have a SaaS product and we have an SDK. I think this is going to, I think the SDK, especially the SaaS, is really a big deal and really easy to use and fast. But the key thing there for the future is going to be this chip so that you don't
Yep.
need to put a
Yep.
container on your gadget. It just boom.
Yep.
And you can put a 10-cent chip into a temperature sensor.
I can imagine the possibilities and the so many applications that we have, because IoT is just is such an expanding field, and with
Yeah.
more connectivity, high speed connectivity, a lot more sensors are being deployed. So when this comes into play, I guess we are looking at a different ball game altogether, which I think is really awesome. And I wanted to touch on another point, which is with this Codeword technology, we are also looking at other goals, the wider goals, like for example energy efficiency, right? Especially for AI architectures. So do you have
Right.
any comments on that?
Sure. Well, and it becomes very clear, like when you're talking about moving data around, you're talking about using power. If we can send a quarter of the amount of data that you're sending now, then you're going to use a lot less power. I mean, that just follows. And in data centers, so we're now just opening up with a discussion with some data center suppliers, make the boxes that go in there and in the pipes. And if we can implement this fully in a data center, it will probably significantly reduce the amount of data that's moving around in a data center, which is constant in lots. And then the other big deal there with data centers is we can, all right, it gets even wilder. And it's because the runtime executable is so small and so efficient that you could, and it's built for speed. And so you could put it on a chip and you could have one chip even talking to another chip on a logic board faster and more efficiently. And even between subsystems inside of a chip can move faster data back and forth. And so we should be able to save significant power. And I'm talking like not next week or something, but this is where we're going. And eventually, we're talking about a massive impact on the amount of power and extending the life potentially of a lot of equipment. Like I was interviewed by Kevin O'Leary a couple of months ago, and that was the point he hit on bang right away, was that this could mean instead of changing out all your gear out of a data center every 2 years, you could extend it to 3 because you have a lot more efficient, a lot faster, data's moving around quicker, and the chips are faster. I mean, we can speed up chips.
Yep.
Because everything is affected by this. It's the basic structure of data.
Wow, that sounds really interesting. And this one other thing that I wanted to just ask, which is the conversion of data, like from all the raw inputs that you gather from all the sensors, converting it to code words, right? So who does that? Application owners, or is it the data owners, or is it, like you mentioned, data centers as well, right? So who's in charge of that and keeping those code words and the code books? Who does that
Yeah,
yeah.
it's all handled by the application. I mean, so the product will automatically, it'll take the way it really works. Let's talk about how the SaaS works. So you you connect up whatever the thing is, like say it's a gateway in Timbuktu, and
Yeah.
it starts sending its data, and the first 100K or so, the inside the cloud, our cloud, it builds a code book, and it puts it in a container and sends it out to Timbuktu and puts it in that gateway. And now the gateway starts sending its data encoded with code words, and that whole process from the moment you you start to set it up to when the code words are flowing is about 4 or 5 minutes, because it's really simple, quick setup. That was a huge emphasis. Well, for us, we have to be as solid as the backbone of AWS or anything. I mean, we're talking
Yeah.
giant companies who this is the data they depend on. We can't mess it up. And the other big deal is it has to be really simple and fast. I mean, nobody wants to screw around with something that's going to take, an hour to set up a connector, right? You just want boom, just click, boom.
Yep.
So the net is the way the whole thing works is very automatic. And so right now, it all just sits in our cloud. We build a code book, push it out in a container, and it maintains it. It says, and then usually it'll sample it over a day and then say, okay, I've got a better code book, put it out, and all that stuff. So it'll build code books whenever it needs them. Most of the time, you get pretty close to optimal right away, and it usually doesn't change much.
Okay, so the deployment would be pretty simple. It still the process lies with the application owners. So I guess that's the workflow for to acquire this much compact data architecture, right? So so basically it's just making things faster, easier, and much lighter on today's networks, especially data center networks. They're going to deal with all these applications, all the IoT data. So I guess, interesting times ahead.
Absolutely. Well, and we're just getting off the ground in terms of making this into what it can be. I mean, yeah, we have big companies and all that stuff, but if you look at where this can go and you really step back and start to think about it, if you can rethink how data is structured to be 4 times more efficient everywhere in everything, then you're really talking about something that can change the world. I mean,
Exactly.
it can impact everything. So we're excited about it. I think we think this is like an amazing thing and I'll be honest, I mean, when we started this thing, nobody really understood the full implications. They thought, well, this could be an efficient new compression. But it just goes way beyond that because of all these things we've considered and thought of and some brilliant people we have working with us.
Fantastic. Well, I guess, we've covered quite a bit today. A very new concept, Codewords, Codewords technology. Okay, and we look forward to hearing more about this. And with that, I think we have come to the end of the session. Thank you so much, Charles, for sharing all these
Thank you,
insights
Sarah.
and for educating all of us on this concept. We look forward, to seeing what Atombeam will be doing in the coming months and coming years. So thank you.
Thank you very much, and thank you again for having me.
Awesome. And to everyone tuning in, thank you guys for listening. If you want to learn more, visit www.atombeamtech.com and follow us for more updates and insights as we continue to uncover the latest in technology and telecommunications. See you in our next session. Bye-bye.